right, this is going to be a problem this is going to be a video rather. How to go over, how to do problem number 4 on the graphical and component vector worksheet. So we got CC, no, it wasn't CC, Juliana, CC's not in the problem, yada yada. We move all the way down past the whole rigmarole, and we see there's 4 vectors. Okay, there's 4.3 going left, 6.1 going at negative 90 degrees, 14.7 going at negative 285, and 9 meters going at 134. Now, I have decided to sketch this on the board. Again, I want to reiterate that you do not have to sketch it. So actually, I'm going to show you the sketch so we see what's happening, but then I'll probably erase it before we keep going here. So let's go ahead and pull that up. All right. So maybe, let's try again. There we are. Okay. So the one where it says left, that's another way of saying 180 degrees. So there's the first vector. The negative 90 is straight down. So there's the second vector. This one was up at 285. Again, it's a sketch. I think it should probably be more up. But there's negative 90, negative 180. That'd be negative 270. Oh, I was wrong, wasn't I? I said 285. Okay, so that isn't right. Oh, nobody stopped me. 285 should actually be in the first quadrant. So 285 should actually be this way because it's past 270. And then our R4 is in 134, so it's going to be somewhere up over here. So we're pretty darn sure still that our final resultant from the beginning to the end, or the total, should still probably be in the second quadrant if we've done this correctly. So this is the sketch. Again, like I said, erase it, to show you the work that we need to do. So for the first one, we're going to find the components of each vector. So let's start with that first one there, the 4.3 meters left. All right. Now for this problem, I am going to show you the way that you can always do it. So you kind of do it just not having to think about it. And I'm also going to show you the shortcut. How do we get the x? Well, we take the magnitude, 4.3, and then we take the cosine of the angle. If it went left, the angle would be 180 degrees. And this is 4.3 meters sine of 180 degrees. Now you remember with 180 degrees that the cosine is in fact negative 1. So the x is negative 4.3 meters x hat. And the sine is 0. So the y is 0 meters y hat. Now, why don't you really need to do the trig? Let me draw the vector and show you that you could have done all this on your own. If this is the vector, 4.3 meters, all the trig is doing is saying how much about that's on the x. You don't need trig to show you that all of it's on the x. So 4.3. Why is it negative? Simply because it's headed in the negative x direction. So you could simply do that yourself. Also, how much of this is on the y? None of it. You can easily see that. So if it's a straight line like this, I'm completely fine if you don't show me these steps and you simply skip to those right there. So that being said, we're going to see this again now for the second vector, which was 6.1 meters at negative 90 degrees. Again, I could do the trig, but I really don't have to. What is the x? The x is 0. None of it's going on the x. Now, if you don't understand that, just stick with your standard magnitude times cosine of the angle. It's going to tell you the same thing. 6.1 cosine of negative 90, it's going to spit out 0. y2 is negative 6.1. Y negative, because it's going down. Y 6.1, because all of it is on the y-axis. Now, let's do the other two. They're relatively straightforward. The third one is simply going to be, what is the third vector? 14.7 meters. Cosine of negative 285. If you wanted to switch that to, 75, you could have. And then y2 is 14.7 meters. Sine of negative 285. Oh, sorry, not 2, 3. And then the fourth one, x4 and y4. x4 is going to be 9 meters. Cosine of 134. And 9 meters sine of 134. just spit out the answers here real quick. This should be 3.8 meters x hat. This should be 14.2 meters y hat. This should be negative 6.25 meters x hat. And this should be 6.47? Yeah, meters y. So the first thing that we do in any kinematics problem, that's down. Any component vector addition is we take each vector and we split it into its component form. How much is going in the x and how much is going in the y. After that, the next step is really the bulk of, this is trig. The bulk of the actual components is simply add all the x's, which way they're going, and add all the y's. So x total is simply equal to x1 plus x2 plus x3 plus x4. Or x1 is negative 4.3 meters x hat. x2 is 0. x3 is positive 3.8. And x4 is negative 6.25 meters x hat. Add those all up together and you get a total of negative 6.75. And we do the same thing for the y. We added all the x's, now let's add all the y. y1 plus y2 plus y3 plus y4. y1 is 0. If you didn't write the 0, that's fine. Negative 6.1 meters. Then positive 14.2 meters. And then positive 6.47 meters. Add those all up, and you get a total of 14.57. Like I said the other day, technically this is in fact the right answer. If I were to draw this down, essentially what I'm saying is that the final is negative 6.25 meters this way, and positive 14.57 meters that way. And that is the final vector. Now, as I've said multiple times, that is technically a correct answer. But right now, I'm specifying that you need to put it back in polar form, which is, in other words, we have this side, we want the magnitude, Pythagorean theorem, and what's the angle? This guy, inverse tangent. So, total magnitude is equal to x total squared plus y total squared, square root, the whole thing, and you get an answer of a magnitude of 16.06. Let's just go 16.1 meters. And the angle, oops, I'm losing it here. I'm going to go there. The angle is the inverse tangent of, make sure you put y on top, 14.57 meters y hat over negative 6.75 meters x hat. And the angle that your calculator will spit out is negative 65.2. But you got to be smarter than your calculator. That is in the fourth quadrant. We can see from our signs here, negative x, positive y, in addition to our original sketch, that should be in the second quadrant. So we fix that by simply adding 180 degrees. So our final answer is 16.1 meters at 114.8 degrees. So, again, nutshell. Take all your vectors, split them into their x and y. Add the x and y's. Technically, you have the right answer right there. But if I ask you to make that additional step back to polar, then you would find the magnitude and angle with Pythagorean theorem, inverse tangent. That's how you do a component.